Hi there, this is Professor Eckhouse, and I'm going to talk today about operations on rational expressions. So remember, an expression is not an equation, so this doesn't equal anything. We're just going to be simplifying things. All right, so starting out with a rational number. What is a rational number? So a rational number, thinking back to just fractions, a rational number is something that can be expressed as basically a fraction. So an integer is on top and an integer is on the bottom. Square root of 2 is irrational because it cannot be expressed as a fraction. There are no two numbers that can give us square root of 2. And when you look at the decimal, it goes on forever. But we're not going to worry about that right now. The idea is that a rational number can be expressed as a fraction of two integers. Whereas a rational expression is a fraction of two polynomials. So instead of having an integer on top and an integer on the bottom, we have a rational expression made up of two polynomials, a polynomial on top and a polynomial on the bottom. So an example would be 3x squared over 5y cubed. Another one is 2x plus 5 over this long thing on the bottom. And it goes on forever. Okay, so all of these are considered rational expressions. All right, so remember, a fraction is just a ratio. So where do you think the term rational number or rational expression comes from? It comes from the root ratio, right? Ratio. It's a ratio. Okay, so let's think about some things with rational expressions. And one of the most important things that you need to remember is the major rule with fractions. What is one thing we cannot do when we have a fraction? So if we have A over B, B cannot equal 0, right? Whatever's on the bottom cannot equal 0. So what's going to happen if we evaluate x squared over x minus 2 at x equals 2? So we're going to plug x equals 2 in for x, and we're going to get 2 squared on top over 2 minus 2. All right, so that gives us 4 on top, and on the bottom we get 0. Can we do that? No. So this is restricted. So the domain is all the possible values, the x values, for a function. Remember, that's what we've always said, all the possible x values. So the domain of a rational function is a collection of all values for the input. So that's always true. A collection of all the values for the input, that's the domain. But of a rational function, I'm going to change colors because this is very specific for a rational function. That will not result in division by 0. All right, so that's always how we start. That's the definition of domain, a collection of all the values for the input. That will not result in division by 0 is specific to a rational function. All right, so we're going to look at what is the domain for these following expressions. So pause the video and see what you can come up with. All right, so this first one, x plus 3 over x. The domain is everything except where x equals 0, right? X cannot equal 0. So it's a collection of all values aside from where x equals 0. So we're just going to say x can't equal 0. Now we could say negative infinity up to 0, union with 0 up to infinity, but we decided to give that a break for this section and just focus on making sure you understand what it can't be, right? So this is the interval notation, but we're just going to ask you in this section to answer like that, just to keep it simple. All right, so for this one, what we've got here is that x plus 2 cannot equal 0, right? That's the bottom of the denominator. The denominator cannot equal 0. All right, so I'm going to subtract 2 from both sides, and maybe you already see it, but x cannot equal negative 2. So if I put negative 2 in right there, I would get 0 on the bottom. Can't do that. Okay, so there's our answer right there. All right, the next one, this part right here cannot equal 0. So let's set that up. 2x minus 5 cannot equal 0. Add 5 to both sides, and I get 2x cannot equal 5. Divide by 2, and I have x cannot equal 5 over 2. Right, so that is, our domain is all real numbers except for 5/2. All right. What about this one? So, no different. It's just that x squared minus 3x minus 10 cannot equal 0. All right, well, let's just factor it and see what that means. So when we factor this, we get x minus 5 and x plus 2. Keep practicing your factoring because we use it all the time. So x minus 5 cannot equal 0. And you can set this up to be equal to 0 if you want. And then at the very end say, well, that's what it can't be. And that's fine. So that can't be 0. And x plus 2 can't be 0. All right, so x cannot be 5. And x cannot be negative 2. All right. So, and that only works because it's 0, right? That's the only way we can use the 0 factor property. All right, but those are the two things that it cannot be. All right, so let's make sure you understand these terms. You might want to pause the video and see if you can remember what all these things mean. All right, I decided I want some lines so I can draw right straight. All right, a factor. Factors are building blocks of multiplication. Building blocks of multiplication. All right, what about a term? A term is when you have single numbers or variables and numbers connected, or variables and numbers connected by multiplication. So single numbers or variables and numbers connected by multiplication. All right, expression. So an expression is groups of terms, or a group of terms connected by what? What are they connected by? They are connected by addition and subtraction. Right? Addition and subtraction. You can write those out if you want to. All right. Lastly, an equation is two expressions. Two expressions set equal to each other. Okay, so we're going to simplify some rational expressions. So first you need to determine the domain. The excluded values are those values that are going to make the denominator 0. Then we're going to factor the numerator and the denominator, and then we're going to cancel out common factors, just like we do with fractions. Nothing different, except we have to factor. All right, so the hint here, so it says simplify and state the domain. Find the domain before you simplify. All right, so let's look at the top and the bottom of this. So the top doesn't factor, so it's going to stay x plus 9. And the bottom is going to factor. You might want to pause the video and try to practice factoring because everybody needs some practice with this so you can get faster and better. But we're going to get x plus 9 and x plus 3. 9 times 3 is 27. 9 plus 3 is 12. All right, so hopefully you see that we've got, first let's think about what the domain is going to be. So the domain is going to, the domain restrictions, right? The restrictions are going to be x plus 9 cannot equal 0, and x plus 3 cannot equal 0. So x cannot equal negative 9, and x cannot equal negative 3. Okay, so those are the domain restrictions. And then we are going to simplify this by canceling out any factors that cancel. So remember, this is one big factor right there. You can put parentheses around it if you want, and then see that x plus 9 is going to cancel. You can only cancel things top and bottom if they are factors. That's the only way you can do it. All right, so this means that this equals 1 over x plus 3, where x can't equal 9 and x can't equal negative 3. So if you factored first and got this, it would look like the only restriction is negative 3. You need to find the restrictions first. All right. So give this one a try if you'd like, and then come back and see how you did. All right, so the top is going to factor to be x plus 6 and x minus 2. Double check, minus 2 times 6 is negative 12. 6 minus 2 is 4. All right, and on the bottom, we have x plus 6 and x plus 3. And again, I encourage you to keep pausing the video and try to factor these yourself. I think it will really pay off if you keep practicing that instead of just watching me do it. All right, so domain restrictions, I'm just going to say domain, is going to be all real numbers, except, right, except where x plus 6, I'm going to do this a little differently so you can see there's a couple different ways to think about it, where x plus 6 equals 0 and where x plus 3 equals 0. All right, so that means where x equals negative 6 and where x equals negative 3. All right, so all real numbers except, so here's kind of how we would say it, all real numbers except x equals negative 6 and x equals negative 3. All right, so let's continue on with the problem and simplifying. So x plus 6 is going to cancel out, and we get x minus 2 and x plus 3. For those of you who are thinking about asymptotes, there is going to be an asymptote, a vertical one, at x equals negative 3, and there's going to be a hole. It's a hole right there. You can graph it and take a look and see, but that's what you would get there. And when you get to precalculus, you'll see why. Okay, so try this one. All right, so on top, we factor and we get x plus 5 and x plus 1. On the bottom, we factor and we get x minus 3 and x plus 1. So let's find the domain. It's going to be all real numbers except where x minus 3 equals 0 and where x plus 1 equals 0. So where x equals 3 and x equals negative 1. All real numbers except x equals 3 and x equals negative 1. All right, so now x plus 1 is going to cancel, and we're going to get x plus 5 and x minus 3 on the bottom. So there's our simplified version of that. All right. So let's simplify and state the domain for this one. Pause the video, practice factoring, and give it a try. Okay, so the top factors to be, this is the difference of two perfect squares, x squared minus 3 squared. So we get x plus 3 and x minus 3. And then on the bottom, we get x minus 1 and x minus 3. So remember, they have to multiply to be a positive 3 and add to be a negative 4. All right, so the domain is going to be all real numbers except where x minus 1 equals 0 and where x minus 3 equals 0. And you can start to do this in your head. If you can just see what those numbers would be, that's totally fine. So that is where x equals 1 and where x equals 3. All right, so let's continue on with this. So what cancels? And the x minus 3 factor cancels out. And we get x plus 3 over x minus 1. And that's what it's simplified to. Okay, give this one a try. All right, so here we have on top x plus 8 and x plus 1, and that is over, let's see, looks like an x factors out of this. So we're going to get x squared minus 6x minus 7. So we're going to have an x out front, and then we'll factor that trinomial. So we'll have an x plus and an x minus. All right, so I get x plus 1 and x minus 7. All right, so let's see what our domain is here. So the domain is going to be all real numbers except, all right, so now there's 3 factors. Don't forget that there's a factor as well. So we have where x equals 0, because this whole thing, remember, this whole thing can't equal 0. And because we're looking at factors, we have to look at each separate factor. So it can't equal 0, right? I'm going to get rid of that because it's messing up my process up here. So, all right, so we've got x plus 1 equals 0, and we've got x minus 7 equals 0. Those are all the places that would make the denominator 0. So all real numbers except where x equals 0, where it equals -1, and where it equals 7. All right, so let's see what cancels here, and I end up with x plus 1 canceling out. So those are going to divide out, and on top I'm left with x plus 8. And on the bottom I've got x times x minus 7. Okay, and that is our answer, our simplified answer. It doesn't simplify anymore. You could multiply this bottom part out to be x squared minus 7x, but we generally leave it factored so that when we go to do more stuff with it, it's already factored, and we can factor more if we need to. All right, so we're going to look at multiplying and dividing rational expressions now. So remember, there's 2 ways to multiply fractions, thinking back to fractions. If you have 4 over 5 times 9 over 8, that's 36 over 40, and then you could factor everything and cancel out. I generally don't do it that way because it's more steps. I like to take less steps. So I take my 4 and I would factor it out. I would factor out the 9 right away and then start canceling things out right away. So you can do either way you want. So this first one, we're going to multiply using either method and state the product in simplest form. So remember, when something's on the top and something's on the bottom, like we had here, you can cancel it out, because when we multiply 2 fractions like we have right here, we can just combine everything together on the top and combine everything on the bottom. All right, so keep that in mind as we do this. These are just multiplied together. So one way to think about this is to think, well, this is 3 times 7 times x, and on the bottom we have 2 times 7 times 3 times 5. Okay, so that 2 times 7 is 14, 3 times 5 is 15. And then we've got 5 x's, 1, 2, 3, 4, 5. But now you know the exponent rules, you really shouldn't need to expand out your x's like that. You might need to with the numbers though, so that's fine. The 7's are going to cancel and the 3's are going to cancel. And you're going to be left here with x squared over 2 times 5. So we've got a 2 and a 5 left on the bottom. So that's 10. And the x's, what cancels here with the x's? Well, 2 x's cancel out top and bottom. And I'm left with 3 x's multiplied together. So that's x cubed. Shouldn't have put that there, should I? got ahead of myself. So there should be a 1 on top. Okay, so that's one way to do it. Another way is to go ahead and multiply out the top. So 3 times 7 is 21, and we've got an x squared. And on the bottom, if you multiply that, you get 210. We got kind of lucky though, because hopefully you see right away that 21 goes into 210 10 times. So 21 divided by 21 is 1. 210 divided by 21 is 10. And then if we use the exponent rules, you're going to say that there are 3 left here. So that's another way to do it. And you'll have nothing left on top but a 1, and then 10x to the third. A couple different ways to do it. All right, so now we're going to do something sort of similar with this. We're just going to factor out the top, anything that factors before we cancel. So on the top, I'm going to work with this one first. So I've got x plus 8 and x plus 4. And you can check that if you want. And then times 3. You can put the 3 out front if you want to. And then I've got this x plus 4 and x plus 8. Now remember, we're multiplying. So whatever's on the bottom here, whatever's on the bottom is just multiplied together. So now what cancels? Well, the x over x plus 8 cancels, and the x plus 4 cancels, and all I'm left with here is 3. That's it. All right, so let's try another one. See what you can do with this. See how far you can get with it without any help. All right, so I'll try to use colors here. This one is going to factor 2. And now remember, this is 5 squared, so this is the difference of squares. So we get x plus 5, x minus 5, and then we've got here the x plus 4. All right, so they're all multiplied together. This is just gonna drive me batty, so I'm gonna fix this, and so it's straight. There we go. All right. Okay, so now let's look at, do some purple on that one, and let's factor it. So it factors 2, x minus 5, and x plus 4. Let's double check that. I get negative 20, and I get negative x. All right, and then the last one is the 8x, so I'll write it like that. All right, so now notice we're not worrying right now about domain. I want to focus more on this process. So I've got an x minus 5, and I've got an x plus 4 that cancel out, and I'm left with x plus 5 on top and 8x on the bottom. So that's simplified down to that. All right, here's another one. Whew, look at that. Pause the video and give it a try. All right, so let's factor this one. And that one factors 2, x plus 5 times x plus 1. Then I'm going to factor this one, and notice they're multiplied together, so I'm just going to put them all together on top. I've got x minus 5 and x minus 2. That's that one. All right, then I've got x squared minus 25. So remember, this is 5 squared, so x squared minus 5 squared, difference of squares. And that becomes x plus 5, x minus 5. And lastly, we've got, again, difference of squares. So this one is just 1 squared. So that's x plus 1 and x minus 1. Difference of squares. Know those well. All right, the x plus 5 is going to cancel. What else cancels? I see an x plus 1 canceling. Oh, and I see an x minus 5 canceling. Look at that. So this whole big mess cancels down to x minus 2 over x minus 1. All right, so the similarities and differences between a rational number and a rational expression. So they're basically a very similar thing, right? So think about the similarities and differences between a rational number and a rational expression. We can talk about that in class, and I just want you to think about it. All right, so let's divide rational expressions. Dividing a fraction is the same thing as multiplying its reciprocal. So let's just think about this with numbers. So if I've got 1/2 divided by 3/4, that means, and there's a little saying that you can do, keep the first one, change to multiplication, and flip the second one. The last thing, the second fraction. All right, so I've got keep, change to multiplication, flip the second one. And then we would simplify 1 times 4 and 2 times 3, and the 4s would, and the 2 would cancel out, and you would end up with 2/3. All right, so the domain, because this ends up in the bottom, the domain will be based on the numerator of the divisor when you're thinking about the domain. All right, so state the domain. Well, the domain, because this is going to end up flipping over, the domain is based on this, which means a cannot be 0. A cannot be 0. Okay, so let's look and see why. So remember, keep the first one, 5a squared over 8, change to multiplication, and flip the second one, 24 over 15a to the 6. So see now why a cannot be 0, because it is actually on the bottom, because division is the reciprocal of multiplication. Okay, so what cancels? Let's think about that first. So I've got a 5 on the top and a 15 on the bottom. 5 goes into 5 one time and into 15 3 times. I've got an 8 on the bottom and a 24 on top. 8 goes into itself one time and into 24 3 times. Oh, and look, now my 3's cancel out, so I've got a 3 and a 3. Oh, the numbers are all gone. All right, so now let's just rewrite this so we can think about it. We've got a squared over a to the 6. And remember, this is quotient rule, so a to the 2 minus 6 is a to the negative 4. So this just becomes 1 over, let me just rewrite that, 1 over a to the 4th. 1 over a to the 4th. All right, number 12. We're not going to worry about the domain. We're just going to do it. So we've got keep the first one, change to multiplication, and flip the second one. So I took the reciprocal. All right, now I've got 9 on top and 3 on the bottom. How many times is 3 going to 3? Once, and into 9 3 times. All right, nothing really cancels. So I've got 3x on top over x minus 2 on the bottom. Does the x cancel? No, it's not a factor right here. It's together with x minus 2. So be careful with that. All right, last one. Why don't you give this one a try by yourself? All right, so we'll color code as we go. So we've got x squared minus 25 again. So x plus 5, hopefully you're understanding this one. X minus 5. Oh, we forgot to flip, didn't we? Forgot that. Oh, I'm going to stop. We'll redo this. Not color code quite yet. So I'm going to have to rewrite it. X squared minus 25 over x squared minus 3x minus 10 times x plus 2 over 7x. And I'm going to put those because those are already as factored as they get. Okay, now I'm going to factor that. And I get x plus 5 and x minus 5. All right, and then we've got, I'm going to just use a little color here like this. And so then I've got x plus 2, so you can tell what's what. All right, and then I'm going to have this factored to be x minus 5, and x plus 2. All right, and then we've got our 7x. All right, so what cancels? All right, we've got x plus 2, and we've got x minus 5. So all I'm left with is x plus 5 on top and 7x on the bottom. Does the x cancel? No, it does not cancel because it is part of this factor right here. And you don't have an x plus 5 on the bottom. All right, so remember you can only cancel out factors, not things that are just simply added to something else. Okay, that's it. Thanks for watching.